Hello students, and welcome to this reminder of how to perform the inverse of a function. So we're finding the inverse of exponential functions today, and our objective is that we will analyze the inverse of exponential functions using our journal notes in a development activity. So you guys got your sheet of paper today, and it's got all these functions on it, right? All of these exponential functions, and you're looking at it, and you're saying to yourself, how in the world am I supposed to find the inverse of these? Well, remember, it's really quite simple. So an inverse function, your x and y values. So if you're given a table, so replace all x values with your y values. So you swap table, so you swap your columns. Swap x and y coordinates for all points. So your inputs are becoming your outputs, and your outputs are becoming your inputs. So let's go ahead and look at what this looks like in our table down below. So if we have 2 to the x, and we want to take its inverse, first we need to develop a table for it, right? So let's start in the middle with 0 here, right? So 2 to the 0 power will be 1. Then if I take 2 to the negative 1 power, that'll be 1/2. And if I take 2 to the negative 2 power, it'll be 1/4. And then we've also got 2 to the first power, which will be 2. We have 2 to the second power, which will be 4. And then we have 2 to the third power, which will be 8. And then finally we have 2 to the fourth. I'm sorry, I keep writing it 2. So this should be 3 and 4. And this will be to the 16th. So remember what each of these is, right? We're saying 2 to the 0 power, 2 to the 1 power, 2 to the 2 power. We're using our exponent as our input. So let's go ahead and graph what this will look like. And I'm going to go ahead and graph this in red. All right, so we have 0, 1. That's a really easy point for us to graph. Then we have 1, 2. Then we have 2, 4. And then it's going to increase beyond our reach. All right, and then we have negative 1, 1/2. And then we have negative 2, 1/4, and we see that it will just approach this x-axis here. All right, and we know the attributes of this, right? We know that the asymptote is going to be y equals 0, and then we also have some other knowledge, and you guys know the range and domain of these, so you know that the domain will be all real numbers, and you know that the range will be everything greater than that asymptote. So it's going to be y is greater than 0, because you can't ever actually reach that 0. So that's your floor. All right, so now let's talk about taking the inverse. So inverse of 2 to the x. So here we have our x values and our y values, and what we're going to do is we're going to swap our columns. So now our x values are 1 to the 4th, and my y value for that will be negative 2. And then my x value is going to be 1/2, and my y value is going to be negative 1. Then I've got 1, 0, 2, 1, 4, 2, 8, 3, and then 16, 4. All right, so let's see what that looks like over here. So we've got our graph, and we can see that we've got our point. Let's go ahead and graph 0, 1, right? Or sorry, 1, 0 now is our point. So that's going to be our point. All right, so let's graph 2, 1. All right, so that'll be there. And then we have 4, 1, 2, 3, 4, 2. And then we'll go off our graph from there. And then we've got these fractions. So at 1/2, I'm at negative 1. Then at 1/4, I'm at negative 2. So that's interesting. So it looks as though our function has been reflected across this line. And this is actually exactly what happens each time, is that whenever we're doing a inverse like this, we're actually graphing across the reflection of y equals x. But the best way to do it is to use your points. So now we're actually going to see that our asymptote is now, so your asymptote for something like this is going to be x equals 0. So remember, your range now will be, your range and domain are flipping. So your domain is now going to be x is greater than 0, and your range will be all real numbers because your x and y values switched. So that's what we're doing today, is we're developing the inverse of each of the functions in your packet. If you have any questions, go ahead and email me. I'll see you next week. Goodbye.